First of all, I want to thank everybody for coming here in this beautiful, early evening. And I really like this venue, this place, because it's surrounded in ooze. So it creates this, casual yet very cozy setup. And that's because we have the fantastic sponsor, SAP, who provide this space. And also we have one of our great partner, Arise, sponsoring this event as well. So let's give a round of applause to them. All right, so just to before I get this big party really started, we have three fantastic speakers talking about every single aspect about RAG and Gen AI. I will just throw in some small piece to get you guys entertained. By entertaining, I mean I'll show some paper and architecture diagram. Everybody here should be aware of RAG. It has been a buzzword. Just say RAG again, which should you. But there has been really a lot of fantastic updates on RAG. It's no longer only about toy apps. There's something that's approaching the production readiness and adoption. So that I want to briefly touch on 2 points, which we are seeing in this domain. One is knowledge graph. The other one is multimodality or multimodal search. And both of them can work seamlessly with our product, Milvus vector database, and our commercial offering, Zilliz Cloud. Okay, forgot to introduce myself, but very quickly, I just wear a lot of hats here at Zilliz. I do ecosystem integration. I also lead the developer relations. And in addition to that, we do have a small research team internally, so that's why we have this kind of new information, new insights that we are more than happy to share with the community. So Milvus is a project which really encourages the really focus on the scalability and performance of vector search, and we provide this flexible deploy modes on your notebook and laptop, which is called Milvus Lite. We also have the scalable, like running in billions of vector scale version, which is called Milvus, which is Milvus deployed on Docker and Kubernetes. We also have the commercial offering called Zilliz Cloud, which provides the enterprise readiness, like RBAC, all those enterprise features, and a proprietary indexing engine, like vector search indexing engine, which does even more, even better search performance than the open source Milvus. And both of them works seamlessly with the a lot of partners in this domain, because coming from the search indexing background, I know this search stack is really complex. It's a long chain of a lot of things, so that you probably don't need only vector database to build a search. You probably need a lot of frameworks and tools like evaluation and observability framework from Arise. So that we partner with all those players in this domains, and we provide notebooks and integration tutorials here at our Milvus website. You can check out the documentation page to learn more. And I put the QR code here so that it will be easier to find it. So all of these things are mostly around RAG, even though to my view is just simply just search. Search with a large language model, but RAG sounds a more fancy term, so let's use it. But basically, it just uses vector search and a bunch of other tools like data mining, data connectors to get your data into a vector database so that it can be semantically searchable. And then you get the data retrieved for online serving stage, and then you put them into a large language model's prompt as a context, so that they can assist the LLM to answer the question with more grounded information. And this simple approach works for many cases, but not always. If you have a lot of, say, structured information, or you want to structure the information with a systematic and a scientific way, then knowledge graph is your good friend. So just like this shows, you can establish the connection between individual points of information like we call them entities in the knowledge graph domain, and then do a lot of interesting data mining to extract those entities, to establish these connections. And you can also analyze the relationship between them to, to analyze the communities of those adjacent information, and then do summary. You can do a lot of fancy things there. But the point is that with this, you can do this programmatically, systematically, so that you don't need to hire, say, a bunch of human beings to label data and then to write summary for them. You can have the large language model and machines and your data pipelines do this automatically. So to see this, working in action, we built this demo, which showcases you just need very simple technique like a large language model offline to extract the knowledge entity, and then you can use knowledge embedding to encode those information into vectors and then store them in a vector database like Milvus. And then you just retrieve them at the online phase. This is nothing different than the usual RAG process. But the beauty here is that you can retrieve the entities and relationships that you have mined offline, rather than just the raw chunks. So basically, you have tidy up all the information rather than just treat them however they are like from the original documentation or original document store. So with that, you can establish better relation between them, so that, for example, you can embed them into vectors, and then you can search the origin entity based on the vector similarity. Basically, you do semantic search on the entities and the relations. And then with this, you can explore the subgraph around them, so that you kind of know the associated information around the origin points. And then you can use another large language model to merge the information from the search of entities and the search of relationships, and then re-rank them by assessing the closeness of those information and the user's query. And then you have a lot of like well-thought information. And with this information, you can just send them to large language model for generation, or you can do a little bit more by getting the original text where those entities and relations were extracted from. So with this, it can do a much better job than just the simple naive RAG, because you really put a lot of effort in the offline data mining. You kind of train your system to become an expert of the documents that the enterprise or your organization has. That's really squeezing the last drop of juice from those information, rather than just treating the those documents as raw text chunks, where you're pretty much relying on however those information are organized by human beings who wrote those documents. Say some document may talk about the relation between entity A and B, but not A and C, and you cannot really explore the infinite amount of combination between the information. But with this knowledge graph, this systematic way of doing data mining, you can do that with the system without hiring a lot of human being to do this manual fashion. So that's one thing. Feel free to check more. We have the reference implementation of the approach that I just mentioned in the Milvus IO documentation page. And the other interesting piece about RAG in action is actually multimodality. So the problem of extracting information and doing search for text modality has been relatively well solved, because there was like 2 decades of experience working on search engines. Like Google and Microsoft pretty much have plowed the way through for this. But the interesting piece is that just today, the information is more and more visual heavy. We have a lot of images and videos and the frames of the videos where we need another whole stack of technology to solve them. And the most practical way to do this is through multimodal models. well, it's a weird term. But basically, you can train a, say, deep learning model, a neural network model, which can understand both the text modality of information and the images. And also, even better, you can associate the information expressed in human language and image through this, complex training techniques and by mining the data from the web, from the public web. One of the representative work on this is Magic Lens by Google. And this model is actually public, is open source. So that with this model, the interesting thing that you can build is you can associate an image search query, which used to be just a plain image, with a piece of text as instruction. For example, here's a very fancy demo of it. Like if you just say, I want exactly this image, so that it can just return this exactly rather than similar image to it. And if you say, I want to see the inside of it, or like looking from the inside of this thing, which is kind of bizarre query, but I mean, this model is really fantastic in terms of understanding the intention between the query, so that it can actually return this one, which is looking, outside from this building. And then rather than the previous approaches, which can just return another photo of this building from the outside. It can also, show you like where this building is located at. Like I think it's Palm Islands in that country. And with this kind of approach, we built another demo to showcase an interesting thing called multimodal image search. Some people call it composite image retrieval, which composite means composited with you combine it with text instructions. So in this particular example, we are searching for this giant machine, but I don't want a picture of this machine. I want a picture of the toy, which looks like this, so that the search results, instead of returning you a lot of engineering, like a lot of machines on the road, it actually returns the toy. So we have some other examples, like with a iPhone, a headset. I want a picture of a girl wearing this headset, and it can return that as well. You can play with this which we publish online with that QR code. So this is really futuristic, and I believe there's a lot of Gen AI applications that can be empowered by this kind of technology. And at Milvus, we are, just in addition to make it even more scalable, make it work with hundreds and billions of vectors, we're also trying to work with everybody of you, so that if you have an application which uses this kind of technology and you require some special features, say if you need multi-vector support to store the vector embedding of both text and image, we have that. But we would like to know more, like what you need, what else you need, like if you need more complex data structure, or if you need better performance in some particular scenario, and we want to build that for you. So with that, here are the links where you can find us. This is the GitHub page of the open source Milvus database. And the other one is the fully hosted Milvus on Zilliz Cloud. So that if you want to check more on the tutorials, we also have tutorials on, say, hybrid search for text. You can check out the milvus.io website, where we have more examples, and also the tutorials for using Milvus with a lot of our partners. Well, I think that's it. So let's welcome the first speaker, Yi.
Thank you. Zoom link. Thank you all for coming. No, it's I don't need audio, right? No audio. no audio. Close this, close that. And yeah, actually, at this place, yes, actually. So I did attend, oops, one very long time ago. All right. Thank you all for coming. It's good to see a full house here. Love the South Bay. Let's do more stuff here. So a little bit about me. I was at Apple for 8 years. We started this team called Messaging Apps, but basically we built 2 chatbots, one for WeChat and one for Apple Business Chat. And then January of last year, January 21st of last year, I went to the Scale AI Hackathon and used LLMs for the very first time. So as you can see, I'm somewhat of an expert. Or in a year, you guys are going to be up here. So it's a good place to be. When I used LLMs, I realized everything we built was obsolete. This is only the second time it ever happened in my career. Like literally, you can still use the chatbots. They're still live, right? You can use Apple's, you can use Best Buy's, you can use, Comcast's. And you're just like, which 6-year-old built this, right? And Apple, we have a policy against employing 6-year-olds. So, but it's true. It's like, compared to ChatGPT, you're like, why is this thing so dumb? Why doesn't it understand what I want, right? So I saw that and I'm like, okay, I have to make a change. So I started going to a lot more events just like this, where I met the founder of LlamaIndex. And then I joined LlamaIndex and we shipped a bunch of stuff. So I started LlamaIndex TS, our JavaScript library, and create Llama, Llama Cloud, Llama Parse, worked on a bunch of different cool things there. So, okay, so let's start this off with a quick survey, right? Like I said, I've been using LLM since January last year. Who started building with LLMs this past week? Anybody? No? Oh, okay. You're pretty experienced. Okay. How about this past month? Anybody start this past month? Raise your hand, double check. You guys just not build? Oh, okay, one. Okay, cool. Okay. 2024, this year. Who started building with LLMs this year? Okay, quite a few. Okay. What about last year? Oh, wow, you guys are really an experienced crowd. Okay, last year. Anybody do it before last year? See, you should be up here speaking instead of me, right? Okay. All right. So, okay, I had this talk all done, it was all finished. And then guess what happens last Thursday? OpenAI decides to ruin my entire weekend. So OpenAI came out with this model. Anybody here from OpenAI, by the way? Okay, good. Because I don't want to get my dev day invite like rescinded. Okay, OpenAI is always really good at naming models. So this one they named O1. It's not like GPT or ChatGPT anymore. I don't know how to say it. OpenAI O1. It's a little weird. But have you seen this tweet? It's like, hey, look, everybody's like excited about the strawberry thing. Who doesn't know what the deal is with strawberries? Come on, raise your hand. Okay, there are a few people who are like, what's the deal with the strawberries? I was like, what's the deal with the strawberries? Okay, so the crux of it is that LLMs see tokens, right? They process these tokens, right? So we use, letters and we use words. LLMs use tokens, and what happens is when you ask a question like this, how many R's are there in a strawberry? It first gets tokenized, right? So here you see how many R's in strawberry, and you think, oh, actually, this is exactly how I would read this, right? Each word is a token. But at the same time, if you just tokenize strawberry, now you see that strawberry is 3 tokens, right? So it becomes difficult for the LM. This is the thinking. I'm not an LM researcher, but it becomes difficult for the LM to really say, well, hey, this strawberry is the same as this strawberry, and they both have the same number of R's. So when you would ask GPT-4o, right, how many R's are there in a strawberry? It said there's 2 R's, which is clearly wrong because there's 3 R's, right? We can all count 3. 1, 2, 3. Okay. So now, if you ask O1 preview, tells you 3 R's, right? So we should be really afraid of these models now, right? No, but kidding aside, like basically what O1 is doing is there's like this sort of like reasoning. So actually these tokens here, you can't see them, right? But there's actually additional tokens that are added into the processing. It's not part of your input and it's not part of the output that you see, but there are additional reasoning tokens. And those additional reasoning tokens are essentially giving more instructions to the model. So in ChatGPT, you can actually see a summary of what's going on. It's not the full thing, right? And you see here, it says, I'm noting the timing, trained up to October 2023, answering for September 17th, 2024, which is a little weird. That doesn't have anything to do with it, but that's like basically some of the system messages that they've put in there. Next, I'll tally the R's in Strawberry. So this should, like for folks who have done anything with agents or chain of thought, this should look very familiar, right? This is essentially the model coming up with a plan for how to answer the question. And so really this reasoning or planning that the model is doing is really what's giving it a boost in performance. And how big of a boost? Well, we see here, right? So up until now, on this particular IQ test, all the models were dumber than the average human, right? But now O1 is now smarter than the average human, right? This is a time where we go and shut down Skynet, right? We say, hey, look, it's time to stop, right? No, but this is quite impressive, right? So this is why everybody's so excited about these strawberries, right? Okay, not because they like to eat strawberry ice cream or strawberry shakes or that sort of thing, right? Because it can understand that there are 3 R's in strawberry. Now, using similar techniques, it can actually answer questions and actually smarter than your average human by a little bit over a standard deviation. And so we can see this. This is Riley Goodside. Riley Goodside's been using LLMs a little bit longer than I have. I actually learned how to use LLMs from him. And he asks a question. He says, name an English adjective of Latin origin that begins and ends with the same letter, has 11 letters in total, and for which all vowels in the word are ordered alphabetically. Respond only with your answer. And O1 thought for 8 seconds, and it came up with this word called sententious, which I have no idea what that means, right? So this model here is clearly smarter than me, right? Like this is pretty good. Okay. But there's always a but, right? There's always a but. Okay. So more thinking means more chances to fail. It also means it takes longer, like literally takes longer. But the more chances to fail is the thing I'm going to focus on today. So if you look at the official OpenAI docs, it even says here, right? These models perform best with straightforward prompts. And then for folks who are interested in doing context for retrieval augmented generation, for RAG, they say, hey, be careful, only include the most relevant information, right? So even OpenAI knows that these models are more easily confused, right? So I'm going to show you some examples of how they may be confused. So this is from my friend Han Lee. He works at, I think he works at Moody's. And he did this one. This is also sort of a simple one that GPT-4o had trouble with. It's like, which is larger, 9.11 or 9.8? So who here thinks it's 9.11? Oh, good. Okay. Yes, good. Okay. So 9.8 is the right answer, right? But O1 preview here thinks it's 9.11, right? And you look, it actually has a number of steps that it's taking. Unfortunately, the steps end up confusing it more than directing it towards the right answer, right? Here's one that I had. This is actually my first interaction with O1 preview. I'm not going to ask the strawberry question, right? Obviously, they fixed the strawberry thing. So I'm like, how many R's are there in raspberry? Thought about it for a second, and it says 3 instances of R. Carefully considering, assessing each letter's position. So there's 3 R's in raspberry, which is correct, right? Correct? Okay. So, but then I said, how many P's? How about peas, right? And it says 2 peas in raspberry. How many peas are there in raspberry? Does anybody know? 1 pea, right? So clearly there's a problem here, right? And so you might be thinking, well, you're unfair, you're picking on the model, it's just hallucinated one time, right? Which is true, actually, because if you try this again on yours, I tried it again and it picked it at 1 p. But let's talk about hallucinations for a second, right? So this is 4.0. This is the simplest version of this question, right? How many S's are there in strawberry? 1 S. I'm sorry, I feel like I'm doing an exam here, but hopefully you guys are still keeping up. Okay, 1 S, right? GPT 4.0 also says 1 S. But if I ask 01, it says there are 200 seeds on an average strawberry surface. And this is reproducible. You can try this on your own, right? So what happened? Well, it's really interesting here because if you look at the thinking part, the reasoning part, it actually says, oh, I'm going to count the number of S's in strawberry, right? And I figured out there's 1 S. But then what happened was then the model then overrode its reasoning. This is something we've seen with tool calling before. And, I don't have a great word for it, but one of my friends coined this term called positive hallucinations, right? So here, like the model is actually trying to understand better, right? It's like, oh, well, he didn't mean S's, he meant seeds, right? So this is something to be aware of. Like the more the model is thinking, it can overthink and it can actually override both you and its own reasoning. So just fun fact, I mean, literally, I was just trying this stuff, right? And like, I was like, okay, well, trying the strawberry thing. And I was just like, how many R's are there in strawberry? And you see the same thing happen here. But here I actually got the right result, right? So in the thinking, it said, oh, hey, there's 2 R's. But then in the conclusion, it's like, oh, no, actually, that's BS. There's really 3 R's, right? So this is sort of like a new type of error mode, if you want to call it, or self-correcting mode, if you want to call it, that you have to think about when using these new models, which I think are going to become more and more popular. So just a few things that I found out about 01. It's still obviously very, very early, right? Like, like literally you can use, for 01 preview, you can use it 30 messages a week, right? So, try it out and let me know what you find. Okay, so that was the division. This is the actual slides that I had prepared for this talk, talking about multimodal and RAG. So that first question, who here hasn't used RAG? Okay, so we have a few. Okay, that means all of the rest of you are RAG experts, right? Right? Okay. So what is RAG? I'm going to ask an audience. Okay, retrieval augmented generation where excellent. So some knowledge base is put into vectors, and that provides some context for the queries. This is a really good answer, actually. So now you guys are familiar with RAG, right? I like to use a different, so retrieval augmented generation, I have a different acronym that I like. It's called BOWS. Better output with search. You see, my words are a lot shorter than the academics, right? So, but you see, I've color coded them, right? So augmented means better, retrieval means search, right? Output means generation here, right? So better output with search. That really is what it is. Like Jiang was saying, right? Like we have this fancy term RAG. What it means is search, right? So this is sort of the standard RAG that my friend explained here, right? This is using Milvus, right? So you have a query come in, you have your documents that are split into chunks, and the chunks go through an embedding model. Then you do a vector similarity search between your user question, which also is embedded, and your document chunks, right? So this is how RAG works, right? This is like, we have like a 5-line starter at LlamaIndex. That's what it does, right? Then you take the question with the context, generate the answer. Okay. So last year when I was here, I coined this term called small to big RAG. I'm not going to have a lot of time to go through it, but it is actually a thing now, so you can look it up. The idea is it's embed small, retrieve big. And the key concept here is that what is embedded does not have to match what is retrieved and given to the LLM. So you can embed a smaller chunk and retrieve a larger chunk. Now, why would you want to do that? The reason why you might want to embed smaller chunks, right? And this is something that you can play with pretty much any framework, you know, how big your chunks are, is because the smaller your chunk, the more concentrated the intent of that chunk, right? So if you have a whole page of text, that's talking about potentially a lot of things. If you have a paragraph, that's talking about less things, right? It's talking about more concentrated things. And then if you have like a sentence, that's like the lowest level. You don't want to go to words, right? Like an individual word doesn't really have much of an intention, but a sentence, you know, subject, verb, object has a very concentrated intention. So you may get better search results. But here's the problem, right? So I have an example, right? I've updated for this one. I'm just going to read it out. Chris Chirillo works in marketing. She is currently VP of marketing at Zilliz, the makers of the Milvus vector database. Prior to that, Ms. Chirillo was VP of marketing at Influx Data. Chris Chirillo is a graduate of Berkeley, go Bears. In her spare time, she enjoys stand-up paddleboarding. Okay, so let's pretend like we have like Milvus running in our brain right now, okay? Once again, you know, you come to talk, you're giving your tests, but anyways, let's try it. So the query that comes in is, where does Ms. Chirillo work? And let's say we have a top K of 3. So we had to pick 3 sentences out of here that match the best with this query. Does anybody have any ideas of which sentence might match the best? VP of marketing at Zilliz, right, my friend? Thank you. Thank you for the answer. I always appreciate it when the audience gives me answers. In this case, your answer was wrong, but it's a good answer, because you would think that is the sentence that you want to retrieve, right, and give to the LM. That is the exact piece of information that you want. But in fact, it's these 3 sentences that are going to be picked. And why is that? Oh, I just told you, you know, hey, look, you know, the embedding model is about intent, and, you know, intent is concentrated, and blah, 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 blah. But there's another thing that's going on here, which is that, remember we talked about tokens? Chirillo is a uncommon set of tokens put together, right? So the embedding model, in order to have good accuracy, will weight that heavily, even though we don't know exactly what's going on in the model. It will weight the sort of like unusual set of tokens more heavily in the search. So any sentence with that set of tokens is going to be prioritized, right? So this is the essence of small to big. So instead of retrieving just a sentence, what you want to do is retrieve this entire paragraph, right? And you say, okay, well, we got matches. We've got 2 matches in one paragraph. Let's just retrieve the entire paragraph and give that to the LLM. Okay, so this is sort of like the thing that we built. It's called small to slide. I built it with Elliot Kang, a friend of mine, contributor to LlamaIndex TS. The idea here is very similar to small to big, right? So what we're doing here is we're going to embed the text and we're going to retrieve an image. And let me show you why that might be helpful, especially in the context of a multimodal LLM. So here's a demo, right? So I've got this loaded up so that you don't have to wait. But basically, the idea is I have this NVIDIA slide deck, right? On the left here, I have RAG, right? And on the right, I have small to slide. And what we're doing here is, here's the context Oops, this should say context. That's a bug. And you see here, basically, because there's images, so they're retrieving in the same slides, but because there are images here, it's actually not comprehending those images. And then if you look at the response here, it gives you the wrong result, right? It said, which software platforms does NVIDIA AI Enterprise support? But if you pass these in to GPT-4o or some other multimodal LLM, and you ask it the same question, you don't even need the text. It says, okay, I've pulled out these things from the images, right? So the multimodal LLM here processes the images, can read them even though they're images, right? And says, okay, I actually got the right results. And we can try that, like, we can say, okay, here. So this one was like software platforms, right? So I pulled these out, right? But like, let's say if we picked like SaaS platforms here, right? We just said, let's give it a second. Everything runs faster when you're not demoing. It's sort of a rule. Okay, so once again here, this isn't very helpful, right? But remember those SaaS platforms, right? It's able to pull those out, and it pulled out every one of them, right? It pulled out 7. So not too bad. Okay. So this is like, once again, something that you can think about if you have a lot of slides, right? Or if you have a lot of PDFs, one way to use the multimodal capabilities of the LM to actually get better results. This works well with graphs. This works well with, mathematical equations. Here, I still did do a transformation step. So there's still a step to do the actual embeddings where I first had to use llama parse to get the text out, right? So the embeddings are with the text, but then what I give to the LM are the images. Okay, but there's something kind of cool going around the internet right now. I want to share with you all. And the idea is, do we need to convert the slide to text at all, right? Because converting slide to text is a little bit error prone, right? Even, that's why llama parse is so popular. If you don't use llama parse, you should use it. But even so, it is a little bit error prone, right? And we're talking about unstructured data. So there's this interesting research out called CoPoly. I encourage folks to check it out. The idea here is that instead of transforming to text, let's skip that step all entirely. Let's just search across the images. So it's a little bit technical, and I'm not the right person to talk about it. But here, instead of having one vector per image, you actually have a whole bunch of vectors per image. And I'll show you an example of what that looks like here. Well, first, let me show the results. So the results are, like, and I literally were for that PDF that they had. I literally just wrote a question for every single page of the PDF, right? And I was like, well, hey, let's just see which ones it pulls out. And it, 1, 2, 3, it basically pulls out the exact correct one. You see this one here that says, it's 4 is like at the end here. Like, I was like, oh, it made a mistake. Haha, I'm smarter. Then I take a look at slide 25. It's actually got the better answer in slide 25. So, and this was true, I'm showing it to 10, but this was true for all 30 pages of that PDF. So it's quite impressive, given the constraints that, hey, you're only searching for pages in one document, right? So there's only 32 options, and you're picking 3 of them, et cetera, et cetera. But how it works is also kind of interesting. So this is from the paper. And basically, you can see that it's sort of like pinpoints. It pinpoints like words and sequences that are more relevant. So once again, not an ML researcher. I kind of think of this as like visual n-grams, right? So n-grams are like, sequences of words. So like 2 character, 3 character, 4 characters. And like in the early days, a lot of search was done this way. So you would search for like 2-character sequences, 3-character sequences, 4-character sequences. Here, what you see is it's finding visual patterns that match your query. And to do the generation part, to do that last part, right, to get the output, it's the same way as small to slide. You're going to generate using the image context, right? So you take the entire image, feed it to the LLM. So a few of the downsides, right? So I've been working with this for a few weeks now. Few of the downsides, it needs GPU, right? And it needs a decent amount of GPU memory. So not something that necessarily is easy as making an API call. I'm trying to get a modal deployable version up, open sourced, so people can try it more easily. Although even that's a little bit challenging because once again, there's the setup and that sort of thing. The models are language and training specific. So for example, Kopali says that it should only be used on A4. But I've actually tried it on other aspect ratios. It seems to work okay. So your mileage may vary. And there's obviously far less exploration and tooling so far. So something interesting to try. But, don't come to me and be like, hey, my boss is mad at me because I tried this thing. Okay. But, so the last part is that the field of RAG is evolving very quickly, right? And so I've just sort of shown 3 methods leveraging these new multimodal LLMs to do better RAG, right? So we have the traditional text-based RAG, which is really good for most use cases. Then, I showed you small to slide, which is just a little tweak on it, very easy to implement. And then we have Kopali, which, is going to require more resources, but could potentially have some really interesting results depending on your use case. So, yeah, I think we're just all learning together. So last favor is I put together this very, very quick survey. The thing is that nobody ever comes to you after a talk and is like, hey, that was the most boring talk I've ever listened to, right? So it's hard to know if the talks are any good. So, if you can just put, do the survey and tell me if this is actually interesting or not, I appreciate it. Thank you very much.
You're always great. By the way, I'm Chris Chirillo, the one that he was using as an example. Any questions from the audience?
Hey, thank you so much for the talk, by the way. So my question is that we saw the example where the model weighted Chirillo more heavily since the unusual number of tokens, right? And I'm wondering why was it designed to weigh a specific number of tokens more heavily than others?
It's not so much the number of tokens, but basically, if you look at the search benchmarks, right, even though we think of vector search as being about intention-based and like really understanding the text, there's still a decent amount of keyword in there, right? Like you would get really bad results on most search benchmarks if you started confusing, a part where somebody was talking about, let's say, Beyonce and like Donald Trump, right? So there's the models, even like what they're trained towards is good search performance. And that requires having a decent sense of unusual keywords.
Interesting. Okay. Okay. Further questions, but later I'll ask you. Thank you.
In the model 01, the example you gave, sorry, echo. There was a scenario where it's overriding its own reasoning. Why does it do that, and what is the logic behind overriding the reasoning?
The answer is I don't know. Okay. When we first noticed this was actually when I was doing this GPT call functions, right? And so when you do function calling, like you give it functions, like what happens if you have a bug? Like you have a multiplication thing and like you're not doing multiplication correctly. For simple multiplication, GPT-4 will say, well, actually, you know what? Hey, you gave it an answer, like what's 3 times 5? And you're like, hey, it's 10. And they're like, no, it's 15, right? My best guess is that as the model has more complicated reasoning, the objective function that they're training towards incentivizes them to sometimes say, hey, you know what? Forget the reasoning. I know what the right answer is, right? And sometimes it does, and sometimes it doesn't, right? It makes our jobs as programmers a little bit more difficult. But that's my guess.
Any other questions?
It's sort of, can you hear me? Yeah. Okay. It's sort of a comment on the O1 thing. So if it's actually on the GPT blog that they're not actually giving the whole chain of thought reasoning. It's kind of a model generated summary. So it's also possible that the summary just kind of got it wrong.
That's absolutely correct. Yeah.
So,
So that was a good point also. That maybe the summary itself is hallucinated, and that's, you know, because they've said, hey, you know, we're not actually going to tell you what the secret sauce is in that reasoning step.
Yeah, they're not being super transparent about the chain of thought reasoning. So yeah, something to just keep it in mind. Yeah.
Yeah,
Thanks
but
for
something in the model is saying, hey, S's should be seeds, and I don't know what it is.
Let's give a round of applause. Thank you so much.
Thank you.
Yeah, thanks for the fantastic talk. So we have our next speaker, Kunal from Northstar, talking about the recommender system. And believe it or not, the recommender system is actually, I think, the first application of vector-based retrieval. It was just, based on this idea of you can do feature engineering and have a lot of things represented as vector, and then with the deep learning model, you can, just use a brute force way to encode any kind of information into vectors and then do semantic search. So without further ado, let's welcome Kunal to give a talk on transformers for RAG.
Good evening, everyone. Am I audible at the end? Is this working? Okay, cool. So, hi, I'm Kunal. I am working as a data scientist at Nordstrom, and I just wanted to share about transformers for rec. It's basically a recommendations library, and it tries to get the sequential and session-based recommendations, which is a great use case for us, given that we are into online shopping and e-commerce, marketplace, so on and so forth. And yeah, so I attended a couple of meetups from Unstructured Data, and then I was interested in sharing this. So yeah, here we go. Okay, so what is transformers for rec? So essentially, NLP transformers library, and this was mainly developed by NVIDIA, and some of the work was done by Meta as well. This library has been open sourced, so feel free to check it out. It's available on GitHub. And the primary objective is to model the sequential and session-based recommendations. So if a user interacts with like few distinct products, can we predict what would be the next recommended items? And it is completely written in PyTorch. It's very well integrated with Hugging Face transformers. The Hugging Face transformers are like the backend architecture of this library. And as of now, I think this is almost the state of the art for transformer architectures if you want to model recommendation-based problems. Okay, so the next question is, why would we want to talk about transformers for rec? So essentially, it is sort of merging or bridging the gap between NLP and recommendation systems. And they're it's definitely not the first library which has come out. If you look at the timeline over here, NLP and recommendation systems have some sort of correlation and overlap in terms of the models which get used. And so transformers for rec is also trying to do the similar thing. If you look at areas like GRU for rec, BERT came out, then BERT for rec came out. Similarly, the attention rank, all of these are recommendation models, and they have like a corresponding natural language processing model. And all of them mostly try to model, the sequential side of the recommendations. So just to draw like some parallels between the sequence modeling and like how the next item or next word prediction would work. So if you look on this side, in this context, if you notice the word light, it is closely related with the word illuminated, which means the light emitted dim light which illuminated the room. So the context is more on the illumination side. But if you look over here, it says the suitcase was surprisingly light as he lifted it. And this essentially the context is more on the weight aspect of it, that the suitcase was light. So the similar sort of context is important when a customer comes and they start searching or browsing the website. So if you look over there, like the two interactions or the two parallels over there are, like for customer one, if they are looking for a shoe, the appropriate recommendations would be more along the lines of socks, jackets, trousers, so on and so forth. But if you look on the other side, if someone is searching for shoes, they might be looking for shirts, jackets, and so on and so forth. So it just depends on like how the customer is trying to interact with your website and what context he or she is trying to model. So essentially, like if someone is shopping on the website and they are very particular about a particular brand, like a lot of customers which visit our website are very interested in Hokas. So no matter what recommendation you give them, they are interested in purchasing Hokas. So trying to model that, they are behind a particular brand. If a customer happens to be a very price sensitive customer, so you have to make sure that the price range of that particular product is reflected in the recommendations as well, which they are interacting with. So that helps, like those use cases are the ones where we want to understand the customer's context very well as to what exactly are they looking for or what kind of product are they looking for. So similarly, like this is just the extension of the previous example. I took this picture from ASOS. ASOS is again an online shopping website, and they are doing something similar where customer one recommendations based on one particular seed item, and then customer two recommendations based on one particular seed item. And essentially just trying to model like for the customer two, the sport shoes would make more sense, whereas for customer one, more on the business casual side, shoes would make more sense. Okay, so now going a little deeper on the model architecture side. So essentially, this is sort of broken down into 4 components. It's fairly modular if you want to use it. So the first part is feature aggregation. It handles categorical features as well as continuous features. So categorical features could be something like your brand or the product type, so on and so forth. Continuous features could be like your price, any discounts, or previous interactions with the product, so on and so forth. And then there is a component of sequence masking, then there is sequence processing, and then there is prediction head. We'll sort of delve a little more into these components. But yeah, this is how essentially that library is laid out. To go a little further into this, so what is exactly feature aggregation? So before feeding your interaction sequence or the products which the customer interacted with to a transformer block, you have to convert it into a standard format. And that is where the feature aggregation module helps you. So if you look over here, the data is based on at a granular level of a user ID or session ID. So if you want to understand a particular user's history, you can stitch it based on a user ID. And if you are interested only in a particular session's interactions, you can stitch your sequence on a session ID as well. Sequence length is essentially just the sequence of the products which the customer has interacted with, then the timestamp and the product ID and the category ID, and then you can have like multiple features which you are interested in. So essentially, you will have to first convert the data into this particular format, and then you can pass it to the transformer. For converting your interaction data into this format, the library also provides a module called NV Tabular, And it's very straightforward if you just want to sort of try it out. It's very convenient. Then the second part is the sequence masking. Sequence masking is essentially the step before you sort of give your transformers the outputs and how it's going to train the model. So it gives you a couple of options. One is the causal language modeling, where in a particular sequence, it's going to mask out like the next items. And then when you feed it to the transformer, it's going to predict the next items. The other could be the masked language modeling, where it can sort of randomly choose a particular product to mask, and then it's going to predict those products which got masked. There are a couple of other techniques. One is the PLM, and then one is RTD. RTD is random token detection. So essentially, it replaces a particular product with a very random product, and then it tries to predict the incorrect product and replace it with the correct product. The PLM is more on the permutation language modeling, where it decides a particular position of a product which will be masked, and then it predicts for that particular position. Then the sequence processing is essentially when you give the transformers your input, and then you try to make a prediction of the products which got masked. For this, it gives you a couple of different architectures to choose from. XLNet is one of the most popular ones, which a lot of people have used. It also provides GPT-2, but in their research paper, I don't think they have found those effective results with GPT-2. So XLNet is like the go-to architecture right now. And this is also, again, a very modular block which they have created. So you can try out a couple of different options and see the evaluation metrics, what work best for your use case. So yeah, this is the sequence processing module. And then there is the prediction head, which is the final module. And in prediction head, you can sort of give a multiple use cases. So one could be the next item prediction, where you are literally just predicting the items. One would be the binary classification, where you sort of estimate the probability of a particular product getting clicked or not. And then regression would be more on the continuous feature side, as in like what is the time when the user comes back to the service, or how much time do they spend browsing a particular product, scrolling it, zooming it, so on and so forth. So basically, your prediction head can have multiple use cases depending on your business context. So you can have like classification-based problems, next item prediction, or even regression-based problems. So this is what like the end-to-end production pipeline would look like. One, I think maybe good or bad thing about this is like it has a lot of hyperparameters which you need to fine tune before you can get to a most optimized model, I suppose. So just choosing your training columns, what features you want to include, then the dropout rate, attention type. It also initializes your embeddings for you randomly. So how do you want to initialize those embeddings? Then the dimensions of embeddings, masking probability, like how much would you want to mask, like 20% of the products to be masked, 30% of the products to be masked. Then the sequence length, how much back or how much behind lag would you want to choose for a customer? Like just is 20 interactions sufficient to make the model, or do you need to go like 30, 40, so on and so forth. The interaction signals, like would you just prefer clicks? Would you just prefer add to bags? Would you just prefer adding it to the wish list, so on and so forth. So you can try out like a couple of different options on that. Number of attention heads, number of training epochs, number of layers in the transformer model. And then the date ranges is essentially like how far back would you want to experiment, or like how far back would you prefer having your historical data. So yeah, I mean, it just takes a little bit of time to get the most optimum model. And so the fine tuning is like a really major aspect of this library. Apart from that, this is what the end-to-end library would look like. You start with the pre-processing. A particular Rex's data set would be your customer interaction data set. and then you get you convert it using the NV tabular module, and then you pre-process it, pass it through the transformers for rec, and then you pass it for the inference. They have the inference facility as well. Like if you don't have one on-prem, you can use NVIDIA's Triton inference server as well. And that is also like fairly convenient to use. It's definitely more on the expensive side, but definitely you can do that. Okay, so in terms of the evaluation and challenges which we see, so evaluation, they use like standard metrics like precision at n, recall at n, and NDCG and mean average precision. So these are like very standard metrics used for recommendation systems. And this library also uses the same. The challenges which at least we have faced so far is the GPU costs. Definitely not something which is economic per se. You can definitely do a POC using a Google Colab and using one of those T4 GPUs. But if you have to use like a full-blown production model, it's definitely expensive. And the more number of SKUs or the more number of items you have, this sort of scales according to that. And definitely like a resource heavy library if you want to do like a full scale deployment. Engineering, data science, then vector database infrastructure, inference and deployment endpoints, and model monitoring, and a lot of data maintenance as well. I don't think like this will be like one static model which you can just use for the time. This needs like retraining very regularly because the customer interactions changes, their patterns changes, and the more number of products which you onboard, the more model training this particular library requires. Other than that, the product context is also something which is very important. Like quite a few number of user sessions or the shopping sessions might not help you in identifying the correct product context. So in some cases, you need a lot of historical data to get that right. Then the problem which a lot of items, like the new items face is if the transformer has not seen those items before, it's very difficult to model those items or create recommendations for those items. So we definitely need like extra signals or like a boosting signals if you have like new products which you want to recommend, because just based on the historical data or a popularity bias data, those items are not going to come to the forefront. So yeah, that's the evaluation and the challenges with it. Yeah, at the end, I just want to attach like some resources, blogs, documentations, and research papers. It's a very handy library if you want to try out like a quick POC and see if it works for you in production. And it's open source by NVIDIA. And there is research paper and there is like end-to-end Jupyter notebooks, which are available online if you want to experiment that out. But yeah, but feel free to reach out to me on LinkedIn or if you have any questions. So thank you. Oh.
Can you hear me? Okay, thanks for the presentation. Do you have any results from your
So we
application?
are sort of in the development process. So I don't have like the results right now, but we are doing a lot of offline tests to see like how this works. And hopefully like if we can have something by the holiday season, we're planning to do that.
Go ahead. And the preliminary results, when you compare with like conventional techniques or LSTM or GRU, is it better or?
It's a little better for sure. So we haven't trained like fully based on the clicks right now. We are focusing on like some preliminary interaction signals. So it's definitely better in those aspects. Like you can, for the NDCG part, we were measuring. So it definitely improves by like 2 to 3% for sure.
Thank you.
Another, Any other questions from the audience?
So how large is your catalog and how many recommendations are you typically giving?
So we have like around 300,000 products, and then we are sort of going more on the marketplace side. So not just owning the products, but also like letting others sell their products. So that is sort of increasing right now. But yeah, as of now, it's around 300,000 products.
Because this is released by NVIDIA, does Gaudi support this as well on the Intel side or no?
What support?
Intel Gaudi, would that work on it or it only
I'm not sure about that.
Okay. Thanks for the questions and thanks for the fantastic talk, Kunal. Yeah, let's give a round of applause to Kunal. And I know at the end of the talk, we'll talk about evaluations and just like, building a system for any like search and recommender, you need evaluation and observability to really push it to production. So we'll have our next speaker, Hakan from Arise, talking about, recommendations, talking about evaluations and the observability from Arise.
All right, can everybody hear me in the back? Cool. All right, thanks so much for coming, first of all. Today, first of all, I guess, let me give a quick intro. I am Hakan. I work as a solutions architect at Arise AI. And today I'm gonna actually talk about, like, we had some great talks on like RAG and multimodal RAGs. I kind of want to talk about like how do you actually evaluate them and take them to production. So let's get started. So if you've attended any of my previous talks, like I always start with this slide. Like for the past year, like a lot of people are working on like some AI applications, but like transitioning from a demo to a real product is actually very challenging. Like I think this is right now the biggest challenge that a lot of AI teams are kind of encountering. So what I wanted to do today is like kind of talk about some like open source tools and then some methodologies to kind of make sure that like this transition is not as hard as it sounds. So in order to do that, I want to actually like focus on one big challenge that we see with a lot of AI teams, which is the fact that like any small change that you make to your AI application can actually cause like big performance regressions, right? So let's say you have some sort of AI application and then you change a prompt, you change a model, or like you just change something in your application. And then like there's a chance that might actually like break a use case, or maybe it actually fixes a use case, but you really do not know like if it actually works on like a bunch of other use cases. So there's always like this need to quantify the change that you make to your application in the case of Gen AI and LLMs. So like what I want to do is like kind of focus on this pain and like how to actually kind of overcome this pain if you're actually working on an AI application today. So the main solution that we basically recommend to the teams we work with is this concept called evaluation-driven development. So like if you're actually familiar, like if you worked in the software before, like there's this concept called test-driven development, TDD, right? Where you actually write tests before you actually write the majority of the code. And this is kind of similar, right? It's basically EDD, where you actually do evaluation-driven development. So if you look at here, the main idea is like you first curate a data set of examples. Like this could be like a hallucinated set of examples, or maybe some golden set of examples. And then what you do is like once you make a change to your application, you track those changes as an experiment on top of that data set. So you basically run your change on top of the data set, and then which is basically an experiment, and then you basically evaluate the experiment so that you can actually quantify the change, right? So like whenever you actually make a change in your application, you can be like, okay, this actually change that I did increased my like correctness rate by X% or decreased my hallucination rate by Y%. So that's the whole goal of EDD, evaluation-driven development. So let's look at this EDD process, like from the process of a RAG workflow, or maybe like some complex agentic RAG workflows. So I think you saw like a similar slide like this. This is the third time you're seeing this today, so I don't want to like go through this one by one again, but if you just look at a simple RAG architecture, right? You have a user question coming in, that gets turned into an embedding, and then it goes to a search and retrieval workflow where you retrieve the most relevant documents, and then you basically have a prompt with the user question and the query, which gets fed into your LLM to get a response, right? So this is a basic architecture. You can easily build this like using a vector DB like Milvus or some sort of agent like LlamaIndex or LangChain. It's actually very easy to build. But the question is, in order to do evaluation-driven development, right, how do I get started? Because the first step to do EDD is evaluation. So how do you even evaluate this whole architecture itself? So that's where the concept of LLM evals come in. So I'm curious, like, who is familiar with LLM as a judge as of today? Good, okay. The number keeps increasing every month, which is great. So yeah, in terms of this evaluation workflow, the main idea is like, if you want to evaluate your AI application, you basically take the input and output of your application, like whatever task you're doing, and then you provide it to an evaluation library. In this case, it will be like an open source library called Phoenix from Arise. And then the general idea is you take the input and output, use another LLM as a judge to evaluate that input and output. And the main evaluation criteria is defined in the eval template here. So at the end, you can basically evaluate any task you want by leveraging another LLM as a judge. So let's look at this like from a RAG perspective, right? How do these evals actually work? So let's say I want to evaluate my retrieval building block, right? So I want to actually check if I am even retrieving the right documents from my vector store. So in order to do that, you basically have like the input here, which is the user question, and the output itself is the retrieved documents. And then we have this eval template here that basically checks like, okay, given this user question and given this reference text, are they actually relevant to each other, right? And then an LLM will basically check this and will basically say, okay, this is actually relevant and this is irrelevant. So by doing so, you can actually check if your retriever is working or not. So this is kind of an example for just checking the retrieval aspect. But if you look at the RAG evaluation as a whole, we usually kind of consider two types of evaluations. So the first type is where you have the relevancy evaluation, which is what I just talked about. Like you're evaluating the first part of RAG, which is retrieval. So you're checking, is the retrieved context relevant to user query? But then another important is the response evaluation, where you actually evaluate the generation part as a whole. So this is where you can check for hallucination, correctness, toxicity, or like basically whatever you want. But we basically recommend these two metrics as a starting point, where you check for hallucination. So it's basically checking, like, is the response actually based on the retrieved data? Is it faithful to context? And also, is it even correct? Because there might be cases where it is faithful, but it does not fully answer the question. It's actually missing a few parts. So by using these three metrics, right, relevancy, hallucination, and correctness, you can actually easily have some sort of performance metric attached to your RAG application so that as you make changes, you can actually quantify those changes. And we're actually gonna look at this together in a quick demo I will do on Phoenix, but that was the main RAG evaluation. So this is cool, and it would actually work pretty well for a simple, like a native RAG application. But right now, like as AI teams mature, basically the complexity of RAG applications increase over time. So in order to do that, there's also a need to do more analysis with your knowledge base, with your RAG pipelines. So in order to do that, what Phoenix provides as a tool is this embedding analysis, right? I'm gonna kind of show this in action, but the main idea is you take your query embeddings and your knowledge base embeddings, and then you visualize them in a three-dimensional space and apply a clustering algorithm on top of it so that you can really understand the gaps in your knowledge base. And this is actually very essential for like unstructured RAG use cases, like if you have actually unstructured data, or if you have a multimodal RAG use cases, you can actually have image embeddings listed here, or maybe like audio embeddings, and really leverage this to like find the clusters of data that are not doing well, that are hallucinating, that are like far away from the knowledge base, to really like identify the different gaps in your knowledge base, and basically have some sort of next, like some sort of actionable insight to improve your RAG application. So by having LLM evals and this embedding analysis, you can easily have some sort of protection and observability on your RAG applications. So let's actually look at this in a quick demo. So I'm gonna jump into Phoenix. How many of you heard of Phoenix, by the way? Okay, awesome. So for those of you who have not heard of Phoenix, it's basically an open source tool that you can easily install. It's pip install arise-phoenix. And you can easily connect this to your like LlamaIndex or LangChain application with one line of code. So you just put one line of code like LlamaIndex instrumentation, LangChain instrumentation. And by the way, if any of you use LlamaIndex and LlamaTrace, this is what's working behind the scenes as well. So we have a good partnership with LlamaIndex as well. But with just one line of code, you integrate your application to Phoenix. So once the integration part is complete, what's going to happen is anytime like someone uses your RAG application, or maybe you're doing testing, all your like RAG application questions and answers will automatically get logged here as a trace, right? So for the context of this demo, we basically have a chatbot that is built on top of Arise documentation. So people are asking questions about Arise and receiving a response. So if you look at like an example here, you can see like the question, the answer, and then the evaluations that I just talked about, as well as the latency and token usage. So if I actually click on an example here, what's going to happen is you're going to get to this tracing page and spans page. So the goal of this page is to give you a step-by-step workflow of how this question got answered, right? So for example, a user came in and asked like, how many classes are supported for image segmentation, right? Actually, let me pick another example that's hallucinated maybe. Okay, we can use this. Do you have an example image segmentation notebook? So you can actually see like what steps it happened to, what steps did it take to answer the question? Like it first changed the query to an embedding, did a retrieval and did a search and retrieval. So you actually see the documents that are retrieved. And again, you can run evaluations here. So I'm actually running my relevance evaluations here on each chunk of document. And then I'm actually seeing there are irrelevant documents here. And then finally, how you can actually synthesize a response using an LLM, right? So you'll have access to your system prompt, user prompt, and output messages. So everything is actually kind of automatically recorded here. And again, all you need is one line of code. If you use something like Crew AI, LangChain, LlamaIndex, OpenAI, everything will automatically get recorded into Phoenix, and you will get to this tracing page, right? So let me actually look at a hallucinated example. So now, on top of this tracing page, you're gonna see that you have these feedback here, right? Which is your evaluations that I just talked about. So what you can do with Phoenix is Phoenix comes with an evaluation framework where you can run on top of your traces and spans that actually will tell you whether like this question and answer pair is hallucinated or not. So it's gonna look at the input, output, and the retrieved context, and it's gonna tell you like, okay, this is hallucinated, and it will also give you an explanation of why it is hallucinated, right? So in this case, for example, it says hallucinated because the reference text only provide information about object detection, specifically about object detection. However, the answer provides a detailed comparison between image segmentation and object detection. So I actually do not have anything in my knowledge base about image segmentation, but there is some sort of hallucination going on here where it actually provides some sort of comparison between object detection and image segmentation. So it's actually providing you like some sort of feedback that it is hallucinated and it is incorrect, right? And on top of this, like as you do your testing workflows, there's also like some need to like actually like some SMEs to come in and label some responses as well. So other than LLM evals, you can also annotate the responses here. Like you can have some labeling team or some other team can come in and also provide like a human feedback to these kind of question and answers as well. But this was the first part, right? The evaluation part. So the next part I do want to focus on is like this evaluation kind of shows me the correctness and hallucination. But if I look at this as a whole, how do I actually leverage embeddings in this case, right? So what I'm gonna do here is like, I'm gonna use Phoenix to look at my embedding data. And I have, again, my query embeddings. So these are the embeddings in blue, and my corpus embeddings. So these are like my knowledge base embeddings. And all of those are actually kind of shown here, as you see. So this is basically like a 3D visualization of my RAG application in action, right? And what I do is like, I actually apply a clustering algorithm on top of this embeddings that I just visualized using UMap, so that I have this clustering and I can pick which metric I'm interested in for like clustering. I can pick like relevancy, I can pick hallucination, faithfulness, or I can pick just the query distance, meaning like how close the queries are to the knowledge base. Like in the case that if the cluster is 100% only queries, that means that like there's no knowledge base embedding next to it or close to it. And you can even like see that here, right? If you look at all these ones, these all look great. But if you look at this one at the top, you actually have like this cluster itself. You actually have, you actually have like a far away anomaly cluster. So if you look at this cluster, I actually see that like these are questions about arise pricing, right? All the similar questions are clustered together. So you can see that like, is there a cost for arise? What is the, how much does the arise platform cost, etc. So again, this is actually a gap in my knowledge base that Phoenix has identified, because like, for example, in this case, I don't have any pricing information in my documentation. It is a gap in my knowledge base, right? So you can do these analysis using this embedding analysis. And again, this even becomes more powerful if you have like a multimodal RAG where you have to use image embeddings as well, so that like you can actually like use embeddings to your advantage to kind of find these gaps, improve your model. Like at this point, what you can do is like, if you want, you can export these, maybe fine tune, or if you want, you can like basically just add pricing information to your knowledge base. So it's really up to you in terms of what you do. But this is kind of like the embedding analysis part of things. Cool. So that was the Phoenix part. Since I have like 5 more minutes, I do want to give a quick sneak peek of our enterprise version, which is actually Arise Enterprise Core. So again, like everything I showed on Phoenix already exists here, but Arise is also like focused on production and a bit on pre-production, where like you still have the same tracing, but what you can actually do is you can actually iterate on your prompt. So let's say that I found a hallucinated example. You can easily jump into Arise's prompt playground and then basically ask Arise to optimize the prompt. So I can basically say hallucinate less. And what's going to happen is it's going to basically run a prompt optimization on top of my data. It's also going to give me a reasoning of what is it doing, like analyzing of original prompt explanation, and it's going to provide me an optimized prompt. Like in this case, it's basically saying like, if the answer is not in context, respond with I don't know. So I can accept this, and then I can run it on my hallucinated example. I can pick any model I want here. So let me pick GPT-4o as an example, and then run this. And then it actually said, I don't know, right? So I kind of just fixed the hallucination in a couple seconds by optimizing the prompt, right? So this is kind of like the next steps that you can take. And going back to the slide I showed, here, like the evaluation-driven development, you can also do this at scale. So as you have your data sets, right? Now that we know like how to do prompt optimization and evals, you can actually have like a data set of like hallucinated examples, data set of golden set of examples, so that like, for example, whenever you push a PR in your application or whenever you make a change in your application, you can run it as an experiment and quantify those changes, right? So for example, like, let's say I started with GPT-4 with some random prompt like that I grabbed for RAG, but then let's say I iterated on my prompt, right? Like I did like 2 minutes ago. Then like I can actually quantify that change. It looks like my factuality rate jumped to 90%. My correctness rate jumped to 90%. So this new prompt really improved my, like this new prompt change really improved my application. Now, like what happens if I go back to GPT 3.5? Like maybe because like I'm cost conscious, I want to do GPT 3.5. It looks like that change actually negatively impacted my application in terms of hallucination and correctness. So again, like going back to the EDD, these are the kind of workflows that you can do once you have a tracing, evals, and some sort of experimentation platform or open source tool to use for any of your AI applications. So that was kind of it. I just want to show like you can use this QR code to get to Phoenix. It's again open source. The Phoenix version I showed, you can just do pep install arise-phoenix. And again, like if you leave us a few stars, that would be great. But yeah, thank you so much.
Well, thank you. Really impressed by the UI and all the the experience powered by Phoenix and the rest. Any questions from the audience about evaluation?
Mic check, mic check. Okay, we're good. Thank you. Great work, great work. I can see how with a kind of like a fixed data set, like building Wikipedia behind your software, how this is pushing an innovative edge. And I really appreciate that. And I love that it's open source, the tech that you're showing me. I'm super curious how you turned that into a business model. That's for coffee later. Question for you though. One of the edges that a lot of us are exploring, I think, right, if we're pushing the edge of innovation with AI, is simulating what it's like to be talking to a person, like someone who gets to know you, right? But the problem with that in vector DBs is that the AI recalling the context that's relevant. It's not just a matter of finding the right memory. Right? It needs to be able to scan over many and pull pieces out. And I haven't seen anyone doing that work. Have you guys been working on that at all in this tech, the ability to scan over many documents in a vector DB, maybe pull 2 or 3 that are relevant out and inject that into the AI?
Yeah, I mean, so I basically showed a very simple RAG where it kind of does that, but like if you do like a corrective RAG, maybe like it actually like corrects itself as it retrieves documents. Like that could be an interesting example. But what you would do is like, so as you use like the large language models, like they improve over time, the context windows increase. So at some point, like the question becomes like, do I need a RAG, or will the context window be large enough that like I don't even need it? I can just put my full document knowledge base into the prompt. I actually don't believe in the latter part. I still believe that RAG is actually very relevant and valuable. It's a matter of how you retrieve those documents and how much you do. So that's where like stuff like Phoenix comes in. Like you can actually test those stuff. Like if you retrieve 3 documents or versus 5 documents, which one is better? Because I can tell you like by experience, 5 over 3 is not always the best. Sometimes it actually leads to hallucination. So it's a matter of like finding the best setup of parameters of how many documents you retrieve, like what's your re-ranking strategy, and then as you iterate on these, like basically quantify that change itself.
Thank you.
Well, one of the takeaway I got from Hakan's talk is that you really want to give constructive feedback to the system, right? Just like how you mentor a human being, you can also mentor it with this evaluation by not only telling that it is bad, but telling you like some kind of information from the knowledge base.
Great presentation, by the way. So I wanted to know that we are using LLM as a judge. So it's giving an evaluation score based on what you have trained it. But how do we judge that LLM as a judge? Like the evaluation score that we are getting over there. Like, is there an EVO benchmark, or is there like an empty bench that we can have an access to so that we can understand that our LLM as a judge is judging it correctly?
Yeah, good question. Very common question. Yeah, Phoenix itself like has all this available information available in their docs. But yeah, what we do is like we obviously do have like some sort of benchmarking. So we have a huge golden data set, like let's say of Q&A pairs, like the question, answer, and some context. And then we basically have human labels attached to them, so that like when you use LLM as a judge, you basically compare those like LLM as a judge results with human labels to understand like how close like GPT-4 gets to human evaluation versus like Claude versus Llama, etc. So we do that benchmarking exercise to pick the right LLM as a judge model, but we always just recommend like using the best model there is, like GPT-4, Claude, etc. And like usually some people like always question like, oh, do I evaluate a GPT-4 application with GPT-4? And the answer is actually yes, because the task of generating based on retrieved documents versus the task of evaluating is actually completely different. The task of generation is a much more harder task than just checking for relevancy, right? So we still recommend using the best models there is, and then we do provide those benchmarking data sets online that you can see.
Hi, great product. So if you want to locally host it and use it, is it possible? And if we have our own LLM judge, can we use those scores and populate the UI you were showing?
Yep, definitely. It's an open source tool, so you can host it. It's in our docs. You can like put it in as a Docker image, or you can do it in a Kubernetes cluster if you want scale. And then you can also build persistence around it. Like if you do it in a notebook, it won't come with persistence, right? If the notebook is terminated, it will go away. But if you host it, have persistence, everything will stay. So that's definitely possible. And yeah, you can use like any custom LLM you have as a judge. Like some people even like have fine-tuned LLMs they use for evals. That's totally possible.
Thank you.
Cool. Thanks so much.
Questions? All right. Thank you so much, Hakan, for giving the fantastic talk. And yeah, thanks. Also, thanks to everybody, staying with us and gone through those very insightful talks.